Well, John Chemistry students, we're going to learn how to balance a chemical reaction under basic conditions. Here's an example. We've got two reactants going to two products. Here's the answer. It's not as simple as you think. Whoa, now I've got like 3 reactants and 3 products. Where did all of this come from? It comes from the steps. Let's practice them. All right, the first step to balancing a chemical reaction that's under basic conditions is to do it under acidic conditions. What? Yeah, it works out much easier. Trust me, I've been doing this for a long time. This is fast and easy this way, easier. So let's see how we do that. All right, step number 1, identify who is oxidizing, who is reducing. The best way to do that is assign the oxidation states of everybody. I have done that for you, so this is a good chance for you to practice it. If you're not sure, you can see that the bromide is going from -1 to 0, so that's being oxidized. And it looks like the manganese +7 going to +2 is being reduced. So we want to be able to split these into half reactions. So put the bromine ones together, that's the oxidation, and the reduction is the manganese ones. Now write all of their ions with them, and then our next step is to now balance the mass and the elements there. So if you look at the bromine, I got Br- going to Br2, the diatomic. And so I'm going to need 2 bromides now to balance out the bromines. All right, so the other thing, what else do we need? Manganese. There's just 1 on the reactant side and 1 on the other. Now they look weird, but if you just look for the subscripts, there's just 1 of each. So we don't need to do any mass balancing there. Okay, so leave that one. Now the next thing we got to do is balance oxygens. And the way that we do that is using water. Now I don't have any oxygens in the oxidation one, so I don't have to worry about that. So I'm going to go on to the next one, and that is with the manganese. Now you see I have 4 oxygens on the left-hand side, the reactant side. So I'm going to use 4 waters to balance the 4 oxygens. Now this introduces hydrogens, but we're going to balance that in the next part in the balancing hydrogen step. Now I don't have to do anything to the first one because I didn't add any oxygens, so I don't have to add any hydrogens. So now I'm going to add 8 hydrogens. This is the step that really emphasizes that we're doing this in acid. And so I've got 8 hydrogens. Why? Because I added 8 hydrogens that were in the water. So I need to add 8 hydrogens. Now this is going to change the charges on the reactant side, but we're going to fix that on the next step. Okay, balance charge with electrons. And so in the first one I have a -2, I have 2 negative charges from the bromine. So I'm going to add 2 electrons to balance that out because it was 0 on the product side. Now this gets a little harder when it comes to this side here with the permanganate. So I have a -1, I have +8 here. So that gives me overall a +7. Now on this side I have a +2 overall when I consider both the water and the manganese +2 ion. So if I add 5 electrons, that will bring the overall charge down to a +2. Now it's balanced in terms of charges on both sides. We don't need to bring it to 0, we just need to bring it to balance. And we use only electrons in this step here. Okay, so that now clears that up. But now I want to make sure I have, I'm going to get rid of the, clear the screen, all right, okay. Now I need to balance the number of electrons from the oxidation and the reduction half reactions. So you can see I have 2 here and I have 5. So I'm going to find a common multiple, which is 10. So I'm going to multiply this one by 5, and I'm going to multiply the bottom reaction by 2. In doing so, that will give me 10 electrons for both half reactions. Okay? So now I'm going to add them together, put all the reactants together, all the products together. Now, once I'm in this stage, I can get rid of the 10 electrons on both sides. I'm trying to find things that are the same on both sides. All right, and I think that's it for now. Notice I have hydrogen ions. That means it's an acid. In order to make this balance in base, I need to convert all of the hydrogen ions, into bases. So for every hydrogen ion, I'm going to add a hydroxide. So I'm going to add 16 hydroxides to both sides. Kind of like a math operation. If you do one thing to one side, you got to do it to the other side. So I'm going to add 16 hydroxides to both sides. That way it's balanced, right? I'm doing something that's balanced to both sides. In doing so, I've created a lot more things there. But I want to focus now on the 16 hydrogens and the 16 hydroxides. They will kind of, in our mind, react and turn into 16 waters. Okay? So now I have 16 waters on the left-hand side, but now I have 8 waters that were remaining on the product side. So I can get rid of these 8, so I'm going to subtract 8 waters, and I'm going to subtract 8 waters off from the reactant side to give me a new total of 8 waters on the reactant side. And so the new thing, though, is the 16 hydroxides. If you do it this way, it's pretty quick and easy, and the charges will stay balanced. Okay? So now I have my new final chemical reaction that I had just written there, and that matches up with what I had already shown. Okay, so the key thing is balance an acid, and then the last part of it right here is you're going to balance it in basic. Okay, sign oxidation numbers, separate, balance the elements, balance oxygen, balance hydrogen, balance the electrons to balance the charge, and then you'll switch over all of the hydrogen ions and the hydroxides by adding hydroxides to both. That's it for now. Hopefully that will give you some pointers as you do the balancing in base.